Generative AI in testing. Generative artificial intelligence, AI, is currently a buzzword in the software industry. Professionals are exploring its applications in various phases of the software development lifecycle. Generative AI, with its creative capabilities, is disrupting industries such as gaming, video and image creation, personalized chatbots, content creation, and the software industry. Since its inception, the testing industry has continuously sought ways to automate testing processes, recognizing manual testing as labor intensive. This has led to a perpetual demand for new methodologies and tools in the testing sector. According to one of the Stack Overflow's 2023 developer survey, 55.17% of professionals expressed interest in using AI for software testing. Generative AI in testing can be explained as a path to achieve greater performance and better accuracy by automating possible tasks involved in manual testing and the lifecycle of quality assurance process. This blog discusses what generative AI is, how it can be implemented in software testing, its applications, benefits, and challenges. Furthermore, we will also shed some light on future trends, developments, and case studies. What is generative AI? Generative AI can be defined as algorithms that help in creating new content, including audio, code, images, text, simulations, and videos. Generative AI can learn from the existing artifacts to generate fresh and authentic content that mirrors the attributes of the training data without duplicating it. It has the ability to generate content across a range of mediums such as images, videos, music, speech, text, software code, and product designs, facilitating the production of varied and unique content. Generative AI employs various evolving techniques, focusing on the AI foundation models. These models are trained on large sets of unlabeled data, allowing them to adapt to various tasks through further fine-tuning. The creation of these trained models necessitates complex mathematical computations and substantial computing resources. However, fundamentally, they operate as prediction algorithms. There are several types of generative AI models with different approaches to generating content. Some of the most prominent types of generative AI models include autoregressive models, generative adversarial networks, GANs, transformer-based models, recurrent neural networks, RNNs, variational autoencoders, VAEs, generative AI in software testing. In the software testing domain, the approach to testing is continuously evolving with the emergence of new technologies. Software testing landscape started with manual testing, where a human tester writes and executes tests according to the requirement. Automation testing has brought about a significant advancement to the field of software testing. In this process, test scripts are designed to execute repetitive test cases, improve efficiency, and reduce manual effort. With advancement, framework-based tools started providing more sophisticated approach in automation testing through comprehensive testing frameworks. These frameworks can include libraries, functions, and methods for building, deploying, and managing test automation scripts. The integration of generative AI into software testing offers an advanced methodology that supplements human testers, expediting the testing process and enhancing its efficiency, thereby elevating the quality of software test outcomes. Utilizing deep learning algorithms and natural language processing, generative AI produces extensive and exceptionally efficient test cases. Additionally, it aids in predictive analysis to optimize testing, intelligent test execution, defect analysis, and comprehensive test maintenance. Application of generative AI in software testing. Generative AI offers various applications in software quality testing, enhancing the efficiency and effectiveness of the testing process. It is applicable to both manual and automated testing methodologies. Here are some applications. Test planning. Generative AI assists QA engineers in selecting the best tools for specific testing requirements, which helps in early identification of potential risks, compatibility issues, and domain benchmarks in the planning phase. Test data generation. Generative AI can create diverse test scenarios by understanding the patterns and relationships within the existing data. This helps in testing various paths and conditions in the software. Edge case testing. Generative models can identify and generate test cases for edge conditions that human testers might overlook. This ensures comprehensive testing, including extreme and unexpected scenarios. Code generation and review. Some generative models can be trained to generate code snippets. These snippets can be used for testing the robustness of code review tools and static analysis tools by creating scenarios with intentionally injected issues. Test script automation. Generative AI can assist in the automatic generation of test scripts based on the requirements or specifications of the said software. This can help in quickly adapting to changes in the software and ensuring test coverage. Anomaly identification. Generative models can learn the normal behavior of a software system and identify anomalies by generating data that deviates from the learned patterns. This can be useful for uncovering unexpected bugs or security vulnerabilities. Scenario exploration. Generative AI can explore different user interactions with the software's UI, helping to uncover potential issues related to user input and interface responsiveness. Data generation for stress testing. Generative AI can be used to simulate large-scale datasets and user interactions, facilitating stress testing to evaluate the performance and scalability of the software under various conditions. Injection attacks. Generative models can be employed to automatically generate test cases for injection attacks, e.g., SQL injection, by creating input data that attempts to exploit vulnerabilities in the software. Adaptive test cases for regression testing. Generative AI can adapt existing test cases to changes in the software, helping in the efficient execution of regression testing when updates or modifications are made. Challenges and considerations. Even though generative AI has a lot of potential in the software testing industry, it poses several challenges in terms of output quality, reliability, and privacy. These issues require human oversight when using the output in software testing, whether it's test data for manual testing or AI-generated code for automated testing. Output can be inconsistent. One of the challenges with generative AI is the output being inconsistent due to the statistical nature of the model. This becomes critical when predictable, repeatable output is desired. The output may also depend on the prompt used for content generation. Prompt engineering, an art or method of crafting prompts to design the output as desired, can address this. Output can be inaccurate. One of the challenges with generative AI is that it may create hallucination, false information, or data. Text-based generative AI models in their current iteration often demonstrate susceptibility to being led astray, fabricating quotes and references, and displaying inconsistency when confronted with challenges. Consequently, they may not consistently serve as a dependable source of truth. This issue can be addressed by repeatedly presenting the same question or prompt, as it's uncommon for models to reproduce identical hallucinations. Therefore, repeating the question aids in smoothing out any inconsistencies. Output may not reflect the real world. Generative AI models are typically trained on data up to a certain cutoff point, which means they cannot generate outputs for the current date. This issue can be challenging where up-to-date knowledge is required. Privacy, security, and copyright issue. While using a public model, we do not have control over the usage and access control of the date we input into the model. Also, content produced by generative AI could lead to a breach of IP laws and it may not be apparent to a user. This can be resolved by using different generative AI tools. Implementation strategy. Any great technology, without an appropriate implementation strategy, fails to realize the benefits it promises, and generative AI is no exception. Even though it can empower testing on many facets, without setting clear objectives for the outcome, it leads to a condition where you sew cloth with scissors. You can keep in mind the following points while using generative AI. Define objective. First thing first, set clear objectives on what you want to achieve through the generative AI based tool. Why is it necessary to use that tool, and what kind of benefits are you looking for? Whether you want to improve test coverage, reduce manual testing efforts, increase bug detection, or you want a combination of these benefits. Determine tool. There are a plethora of tools and models which integrate generative AI into their traditional processes. Each tool is unique with different strengths and weaknesses. We should evaluate whether it is in alignment with the organization's objectives. Analyze infrastructure. Generative AI needs resources with robust computational capability. Assess your existing infrastructure setup and check whether it can or cannot accommodate the AI's requirements. This might involve upgrading hardware or exploring cloud based solutions. Train manpower. You need specific skill set to work with generative AI, and it can be acquired via training and upskilling. Basic training includes fundamentals of generative AI, working with specific tools and understanding its processes, evaluating the results, and debugging the issues needed for successful implementation. Monitor process. After setting clear goals, infrastructure setup, and required training, a continuous monitoring process is required to check the performance. Monitoring the key areas and then other phases of the testing process can help in mitigating any challenges early. Case study. Let's go through a case study on how generative AI enabled superior testing of the Messenger app from Meta. Messenger is a popular app that needs no introduction. However, manual testing was challenging. Users access the app in various ways and on different devices such as mobile, tablet, and laptops, bringing diverse scenarios of app access and use. Identifying so many scenarios and creating test cases manually is a big challenge, and failure impacts the quality of the app and the user experience. Generative AI simulated user interactions in real time and captured the data. This enabled the software to know how users think, versus what the software testers assume while writing test cases. Based on the user interaction data, generative AI generated test cases and data, and then automated the app testing. The main benefits of deploying generative AI were a better understanding of user behavior, a superior testing process, and automated testing. Meta saw improved productivity, higher user satisfaction, fewer bugs, and a better testing workflow. It reinforced the idea that manual testing can capture user intentions to an extent, but generative AI can constantly learn from user behavior and quirks. Generative AI based tools. There are many generative AI based tools in the market that help in one or the other phases of software testing process. There are tools like Test Sigma, Functionize, and Test Trigger that can help in generating test data based on the real world scenarios. Tools like Tosca, Applitals, and Testim help in UI/UX based testing with the use of AI. For scenarios like multi-browser, multi-version, web, and mobile combination testing, tools like Automate by Browser Stack and Sauce Labs can be useful. Tools like GitHub Copilot and Visual Studio IntelliCode help in scripting for test case generation and assist in automation testing, while tools like ChatGPT can be useful for various phases like documentation, code generation, code review, and test planning. Conclusion. The implementation of generative AI in the software testing process can be a great leap forward. A generative AI based tool augments the testing process, standing at its core. With this, the testing process is expected to undergo substantial changes as labor intensive tasks can be automated with the help of AI. However, the benefits it brings are not limited to reducing manual labor and improving testing scope, but enhancing the testing process. If all ethical, privacy, and safety concerns are taken care of, aligned with a clear objective, a properly defined learning curve, and a monitored process implementation strategy, It can yield numerous benefits for the organization in terms of reducing testing efforts and achieving extensive data driven testing coverage. Generative AI is still evolving, and the way different tools are entering the market indicates that organizations are embracing it. It is expected to soon disrupt the software testing process.